LeetCode question 1. We have to calculate the minimum cost to connect n ropes such that two ropes can be connected at once and the cost to connect two ropes is equal to the sum of their length. Here's the input and the output we should get. So now let's try to connect these ropes in the same order as it is given in the question. Now 7 is the length of the new rope which we have obtained by joining 4 and 3. So now let's merge rope 7 and 2. And the cost to merge 7 and 2 is 9. Now we have two ropes of length 9 and 6. The cost to merge this is 15. So the total cost to merge rope 4, 3, 2, 6 will be 7 plus 9 plus 15, which is equal to 31. Now notice that 31 is greater than 29. So this is not the answer and we need to minimize this value. So notice that 7 is equal to 4 plus 3, 9 is 4 plus 3 plus 2, 15 is 4 plus 3 plus 2 plus 6. 4 and 3 have been repeated 3 times, 2 twice and 6 once. So we can see that the number which has been repeated the greatest times should be the least in value and the number which is the highest in value should be repeated the least. So what we can do is we can sort this such that 2, 3, 4, 6 merge ropes 2 and 3. Now 4, 6. Now merge rope 4 and 5, which is 9. Now merge rope 6 plus 9, which is 15. Now if we look at the sum of the cost 5 plus 9 plus 15, this is equal to 29. So we have obtained our answer. Therefore we observe that the least values should be the ropes with the least length should be merged first. So we have two methods to implement this. Look at method 1. We can have an array we can take the two least values, then merge them and then insert in the same array. Now if we have a sorted array, so to merge this is constant, to insert this is order of n, this is also constant. And how long do we have to do? We have to make n minus 1 merges for n ropes. So we have to repeat this process n minus 1 times. So the total order through arrays will be n into n minus 1, which is nearly equal to order of n square. Now let's look at method 2. Can this be any better? So what if we implement a minimum heap? We can insert the values in the heap and then select the two list values from the heap. This will be of the order log n. Now we'll merge the two values and then again insert the merged value, which is again of order log n, and same we'll repeat this process for n minus 1 times. So this all three will collectively be roughly equal to log n. So order will be n minus 1 into log n, which is roughly equal to order of n log n, which is better than order of n square, which we saw earlier through arrays. So now let's head to the implementation vector nq. And this vector is not needed. We can directly take the length of the ropes through the user, but for the sake of simplicity I've used a vector. So now let's make our minimum heap. I've named our heap minimum heap. Let's insert the values of the lengths of the rope. Now initialize a variable total cost, which will be equal to 0 initially. Now we'll keep merging to our minimum heap until only a single value is left in the heap. So fs stands for the first smallest value, which will be at the top of the binary heap. We'll push the values of fs plus ss, which is the cost of merging the smallest first row and the smallest second row. I will say the total cost to 0. Now let's run our program. We have obtained our answer, that is 29.